If you want to master organic chemistry, welcome to Chemistry Not Mystery. You can also visit my website chemistrynotmystery.com. In this video, you will learn one of the key concepts of the organic chemistry. What are the different types of carbon? Stability of carbocation and stability of carboanion. It helps you to compare the stability of intermediate, choose the major product, choose when carbocation undergo rearrangement, determine the acidity order, and determine the basicity order. Let's see the different types of carbon. It can be primary carbon. It is directly bonded with one other carbon. It can be secondary carbon. It is directly bonded with two other carbons. It can be tertiary carbon. It is directly bonded with three other carbons. Or it can be quaternary carbon. It is directly bonded with four other carbons. There is one more classification of carbon. If I take an example of 1-butanol. Here OH is the functional group. So the carbon to which functional group is directly bonded to is called the alpha carbon, and the carbon next to alpha is the beta carbon, and then gamma, and then the delta carbon. We have identified primary, secondary, tertiary and quaternary carbon on the basis of number of alkyl groups attached to it. So what is an alkyl group? You are familiar with alkane, and its general formula is CnH2n+2. So when you remove one of the hydrogen from it, it becomes alkyl with one free valency. For example, if you remove one hydrogen from methane, you will get methyl with one free valence. The alkyl group plays an important role in the stability of carbocation. And to understand it, you need to understand the nature of alkyl group. It is an electron donating group. It donates electron density via inductive effect and through hyperconjugation. Now determine the stability of carbocation. In methyl carbocation, there is non-alkyl group attached to it. In primary carbocation, there is one alkyl group that donates electron density to it and tries to fulfill its deficiency. In secondary carbocation, there are two alkyl groups that donates electron density to it. And in tertiary carbocation, there are three alkyl groups that donate electron density to it. That's why tertiary carbocation is more stable than the secondary, is more stable than primary, and methyl carbocation will be the least stable. Now discuss the stability of carboanion. In methyl carboanion, there is non-alkyl group attached to it. In primary carboanion, there is one alkyl group that donates electron density to it and increases its negative charge, makes it unstable. In secondary carboanion, there are two alkyl groups that donates electron density to it. And in tertiary carboanion, there are three alkyl groups that donate electron density to it and make it more unstable. That's why methyl carbanion is more stable than primary, than secondary, and tertiary carbanion will be the least stable one. From the above discussion, you can understand that the electron donating group increases the stability of carbocation by donating electron density to it. These are the few examples of electron donating groups. Alkyl group, negatively charged atom, electron rich species, conjugation. For example, in vinylic carbocation. Here carbocation is in conjugation with a double bond. It stabilizes carbocation by resonance. Lewis bases like NH2, NR2, etc. OH group, OR group. Similarly, electron withdrawing group increases the stability of carbanion by taking electron density from it. Here are a few examples of electron withdrawing groups like positively charged atoms, electron deficient molecules like BH2, Lewis acids, for example BH2, AlCl2, carbonyl groups like aldehyde, ketone or acid, nitro group, cyano group. In general, you can understand it if there is Z atom bonded with any electronegative element, then this group will act as an electron withdrawing group. Let's solve one problem based on it. Which is the more stable carbocation among them? Here, CH2 minus is an electron donating group. Because of negative charge over it, it will donate more electron density to the carbocation. Here, NH2 also an electron donating group because it has lone pair of electrons. But its donating ability is lesser than that of CH2 negative. Here, fluorine also has lone pair of electrons, but it is the most electronegative element, so it will withdraw electron density from the carbocation. So first one will be the most stable carbocation, then the second and third will be the least stable one.